It's funny. Sometimes the solutions to our biggest problems are hiding in the most unlikely places. Places we usually just want to get rid of, like our trash. Okay, let's get into this because what we throw away might just hold the key to a much more stable future for both our energy and our food.
For the last few years, we've all felt it, right? It's this double whammy that hits us right where it hurts, the wallet. I'm talking about soaring energy bills and, at the same time, climbing food prices. And believe me, it is not a coincidence. These two are deeply, deeply connected.
So let's start with energy. And this is just wow. In just 1 year, natural gas prices for businesses all across Europe went through the roof. We're not talking about a small bump here. We're talking increases of over 250% in some countries. That kind of shock sends ripples through the entire economy, from manufacturing all the way down to, you guessed it, your heating. And then comes the second hit of that 1-2 punch: food. The price of the very stuff farmers rely on to grow what we eat, essential fertilizers, absolutely exploded. I mean, look at this. Urea prices quadrupled, potash tripled. When it costs that much more to grow food, you know exactly where that price hike ends up, right there at the grocery store. So, what's the link? What connects a gas pipeline to a bag of fertilizer? Well, it all boils down to one thing: a heavy, heavy reliance on fossil fuels and other non-renewable resources. And that dependency makes our entire system incredibly fragile and vulnerable to shocks. It's exactly why we need to find a smarter, more circular way of doing things. And that brings us to a really cool shift in perspective. What if we started looking at our waste differently? Instead of just seeing it as a problem to be buried or burned, what if we saw it as a massive, untapped resource right in our own backyards? We're talking specifically about what's called organic wastes. This is all the biodegradable stuff: the food we don't eat, sludge from water treatment plants, manure from farms, leftovers from agriculture, basically anything that came from something that was once alive. And the sheer scale of this stuff is just mind-boggling. Get this. Every single year in Europe, we produce over 1.4 times billion tons of animal manure alone. Then you add in hundreds of millions of tons from our industries, our cities, and our farms, and you've got this enormous, constantly renewing stream of potential value. So what does all that waste actually translate to in terms of energy? Well, if we processed all of it, we could potentially generate over 217,000 million cubic meters of biogas every single year. That is an absolute game changer. That's enough clean energy to make a real, serious dent in our reliance on imported fossil fuels. Okay, so the potential is huge, right? And we already have technologies to convert this waste into value. But here's the catch. Our two main methods each have a pretty critical flaw. They're good, but they're not perfect. On one hand, you've got something called anaerobic digestion. It uses bacteria in an oxygen-free tank to break down waste. And it's fantastic at producing energy, biogas. But the downside is what's left over: this sloppy, unstable material called digestate that can still contain pathogens and contaminants. On the other hand, there's good old composting. It uses oxygen to decompose organic matter. It's brilliant at creating a safe, stable soil product, but it actually consumes energy, and it can lose valuable nutrients like nitrogen in the process. So each one solves a problem, but creates another one. And this leads to a really powerful question. What if we stopped thinking of these as competing technologies? What if we could design a system that takes the best of both worlds and uses their strengths to cancel out their weaknesses? And that is exactly what researchers have figured out. It's an elegant solution called integrated anaerobic digestion and composting, or IADC. It really is a perfect partnership that creates a powerful, synergistic system. Just look at how simple and brilliant this process is. Think of it like a tag team. First, anaerobic digestion steps in and does what it does best. It quickly extracts all the easy energy, producing that valuable biogas. Then it tags in its partner. The leftover digestate is handed off to the composting process, which then finishes the job by stabilizing the material, killing off pathogens, and breaking down those stubborn contaminants. And the end result? Two incredibly valuable products: clean energy and a safe, high-quality biofertilizer. Now, this isn't just some clever waste management trick. This is a perfect example of the circular economy in action. We're taking something nobody wants, waste, and looping it right back into the system as two things we desperately need: renewable energy and sustainable fertilizer. It's a system that directly helps us meet global goals for clean energy, food security, and climate action. So,
The theory is beautiful, but does it actually work in practice? Well, the evidence is clear. We've got proven, data-backed benefits that show this partnership truly does close the loop.
The data on safety and purity is just so impressive. The AIDC process is incredibly effective at removing harmful contaminants, achieving 100% degradation of things like mycotoxins and even certain pharmaceuticals. It can completely break down starch-based bioplastics and remove over 80% of antibiotic resistance genes, which is a huge public health concern. This proves the final product isn't just useful, it is genuinely safe. As the author of the source paper, Mirko Cucina, puts it, this final composting step is the key. It's what transforms that digestate into a product that can safely return valuable nutrients to the soil. We get a high-quality biofertilizer that can replace the synthetic, fossil fuel-based ones that are causing so many of our problems in the first place.
So, we have the science. We have the technology. The final piece of this puzzle isn't technical, it's political. To make this solution mainstream, we need a clear policy roadmap. That means prioritizing waste reduction, setting ambitious recycling targets, and crucially, creating a real, functioning market for these recovered biofertilizers so they can actually compete.
Which brings us to our final question. The science has given us a near-perfect solution to turn our waste into watts and our trash into treasure. The pathway is clear. The only question that remains is whether our policies are ready to follow.